This is my second video lesson for the unit measurement. Today we're going to talk about converting between different units. Let's go to page 7 in the class packet. For motivation, we have 2 questions. I want you to do this yourself. Once you do it yourself, resume this video. In the first one, we have to convert 100 degrees Celsius to Kelvin. To do that, it says to find the equation that's on table T. Okay? So on table T, it tells you the equation. So all we have to do is do 100 plus 273. That's 373 Kelvin. Using the reference table, convert between 202.6 kilopascal to atmosphere. So these are units of pressure, right? So let's look at table A. Notice on table A, it tells you the conversion right over here. 101.3 kilopascal is equal to 1 atmosphere. Okay, now we set up a ratio between the two and we solve for x. If you do that, x is 2 atmosphere. So in both of these questions, I tell you to use the reference table, but on the Regents exam, they're not going to tell you, right? So you must know to look at the reference table to help you with these conversions. Learning target. At the end of the lesson, I will be able to convert from one unit of measurements to another. So I want you to do homework number 2, which is a Junopod, which is based off of this lesson. I am first going to review some definitions since we're doing some counting here. An atom refers to a smallest unit of an element. A molecule is the smallest unit of a covalent substance. I'll discuss what covalent means in the future. A particle can refer to one unit of an atom or molecule. So in this picture, both the atom and the molecule is considered a particle. This is one particle and this is one particle. This is considered one particle, not two, because these two elements are bonding. So now we're going to talk about counting units. These are units used to count stuff. Let's start with one that you're familiar with, which is the dozen. So a dozen is 12 items. So if I have 2 dozens, that is 24 items. So I basically did 12 times 2 equals 24. Now I'm going to introduce you to a new counting unit, which is the mole. A mole is 6.02 times 10 to the 23rd items. So a mole is used the same way as a dozen, okay? So if I have 2 moles, that basically is 2 times 6.02 times 10 to the 23rd. If you plug into your scientific calculator, that is 1.2 times 10 to the 24. So you have to memorize what does a mole equal to, which is 6.02 times 10 to the 23rd, because it's not on the reference table. You must also know and memorize 1 cm cubed is equal to 1 milliliter. So make sure you memorize this, okay? It's not on the reference table. Okay, so these two numbers are scientific notations. So basically, they're used to abbreviate a very big or very small number, right? Because sometimes if you write out the expanded version, which is called the standard notation, it's very inconvenient in figuring out how many decimal places there are. Okay, now here's the general equation on how to convert between units. Your start unit times the desire over the start gives you desired unit. So this is your conversion factor in the middle, right? Let's do an example. So here we want to convert between 7.8 liters to milliliters, right? So how many milliliters is 7.8 liters? So we're given 7.8 liters. What do we want? We want milliliters. So what's the conversion factor between liters and milliliters? If you don't know it, check the reference table, right? 1 liter is 1,000 milliliters, okay? So we're going to go from liters to milliliters. So what's our start unit? Our start unit is liters, okay? And our conversion factor is 1,000 milliliters over liters. So how do we know which one we put on top and bottom? The start unit is always on the bottom because you want it to cancel out mathematically, okay? So notice they cancel out. 7.8 times 1,000 is 7,800 milliliters. In most chemistry textbooks, you'll see this term, dimensional analysis. It basically means unit conversion. So here's a short story. NASA sent out an orbiter a while back to Mars. However, they lost the orbiter because of a unit conversion, and it cost NASA $125 million. So keeping track of units is extremely important in science and in measurements. So remember to include correct units in all your answers. So let's do another example. Here we want to convert 1.5 times 10 to the 23rd atoms to moles of atoms. Right? This might look complicated because we're dealing with a big number, but it's actually not. So we're given atoms, a lot of them, in fact. We want to find the mole. Okay? How many moles is this? So we have to convert 1 mole is 6.02 times 10 to the 23rd. Again, you have to memorize this number. Okay? So 1 mole is this many items. What items are we talking about here? We're talking about atoms. So we're going to go from items to mole, or atoms to mole. So let's write out our equation. So again, for your conversion factor, you want your start unit to be on the bottom. In this case, is atoms. So then we plug this to our calculator. If you're using a scientific calculator, make sure you put parentheses between these scientific notations, or else your calculator is going to read from left to right and give you the wrong answer. Okay, so you're going to do this divided by this, basically, on your calculator. If you do that, you get 0.25 moles. Okay, that's your final answer. Learning trick number 1. How many molecules are in 1.5 mole of water? So this is similar to what we just did. I want you to try to do this yourself. Resume the video once you have the answer. So the answer is 2. So how do we get that? Let's go over the answer. So how many molecules are in 1.5 mole of H2O? So what are we given? We're given the mole, right? What do we want? We want the number of molecules. That's the items. What's the conversion factor? 1 mole is 6.02 times 10 to the 23rd. So we have to go from mole to the number of items, which is molecules in this case. So apply the setup. We have 1.5 mole times 6.02 times 10 to the 23rd molecules over mole. So the mole, which is our start unit, will get canceled out. If we multiply these two numbers, plug into your calculator, you get 9 times 10 to the 23rd molecules. Learning trick number 2. How many atoms are in 1.5 mole of H2O? In the previous question, we solved for the number of molecules, all right? But this time we're asking for the atoms, okay? So I want you to think about how many atoms are in 1 molecule of water. Try to do this yourself, pause the video, and resume once you have the answer. So the answer is 4. So how do we get that? So it's asking for how many atoms are in 1.5 mole of water. So if we have 1 molecule of water, how many atoms is that? So we have 2 hydrogens and 1 oxygen. That'll be 3 atoms, okay? So here we want to go from number of atoms to molecules because we already solved for the molecule in the previous question, okay? So this is what we got from the previous question, right? That's for molecules, right? We have 9 times 10 to the 23rd molecules. There's 3 atoms in 1 molecule. So therefore, we multiply this by 3. That would be 2.7 times 10 to the 24th. This only applies for water. So keep that in mind. Okay? So now I want you to do some practice questions. Part 1, Part 2, and Part 3. I will post the answers on my PowerPoint. Alright? Try to do this yourself. Resume the video to see the answers. Okay, so here's the answers for Part 1. Notice I included units in all my answers. Here are the answers to Part 2. I rounded some of these numbers. As long as your answers are close to these or within the error range, you should be fine. So this concludes the video lesson for today. Remember to do the JunoPod homework.